Hello everyone, Ismail is here. Today we're going to start Modular 4, 4.1, Understanding Polynomial Expressions. This lesson is very easy, boys, girls, and you can find all the lessons on my website, www.farramat.com. Okay, so now this one up for my classes in school. Now let's start with identifying monomials. Okay, first of all, we have something we call monomial. Okay, monomial. So what's the monomial? Monomial is a number or a variables or the product of numbers and the variables with whole number exponent. Okay, and also monomial stands for one or one term, no variables in denominator, no fractional exponent. So as you can see here, we have two things. We can consider them not monomial. So the first one, no variables in denominator, like 5 over x. We can't have this one in the denominator. And no fractional exponent, mean no x1 over 2, no, let's say y square root of y, because square root of y, if you remember, can be written as 1 over 2. Okay, so no fractional exponent. Okay, no, so this type of example of monomial, the number is a monomial, variable is a monomial, number with the variables, okay, also is a monomial. Okay, also decimal number with a variable is a monomial. Okay, here, this one maybe you'll tell teacher why this one is monomial, because the denominator here, it's a number, and the number is a monomial. I told you only the variable, because how can I rewrite this one? So to rewrite this one, I can rewrite it to become 1 over 4 xy. So as you can see here, 1 over 4 is 0.25. So 0.25 xy. So this one is monomial. It's same this one question here. Okay. Now, what are the not monomial here? So the not monomial, because we have two parts, 4 plus x. So this is not monomial. Okay, x minus 1, it's not a monomial, is 0.7 x to the power negative 2. Negative 2, it's not a whole number. Okay, so that's why this one is not monomial. Also, same thing here, negative 1. Negative 1 is not monomial. Here, we have a variable in the denominator, so that's why it's not monomial. Okay, so I hope you understand what's the meaning of monomial. Okay, now let's reflect on what we understand. Now, explain why 16 to the power 1 over 3 is a monomial, but x to the power of 1 over 3 is not monomial. Why? Because 16 to the power 1 over 3 is, you can evaluate this one. You can use your calculator, you can use whatever, and also 16 is a number. 16 is a number. And we know that 16 to the power 1 over 3, you can convert it and solve it and you get an answer. Okay? But here, the variable, okay, which is x, has a power. So this one is square root of 3x. So x is a variable under the square root, or there is a fractional power for a variable. Okay? So that's why x to the power 1 over 3 is not monomial, but 16 over 1 over 3 is a monomial. Okay, now, is x to the power of 0 is a monomial? Explain. Is that right? Yes, it's monomial because x to the power of 0 is equal 1. And 1, is it a monomial or not? Yes, 1 is a monomial because it's just a number. Okay? Don't forget. So if you have only number, always all real or whole number, okay, is a monomial, except if we have a fraction number with a variable, okay, or let's say not fraction number, a fractional exponent, okay, with a variable. Okay, now let's do these questions here. So now we have these terms, 5ab, is it a monomial? Explain your reasoning. Okay, so now the first example, 5ab squared, this is a monomial number with the variables with normal exponent, not fractional. So this one is a monomial. Okay, now this is the reasoning. I don't need to go to the reasoning. Now, number 2, x to the power of 2. Is this x to the power of 2 is a monomial? Yes, it's a monomial because, okay, because it's just a variable with a normal number exponent. Okay, Now, then, 2 to the power of 2, is it a monomial? Yes, it's a monomial. Okay? Then, 5 to the power k to the power of 2. So we have a variable in the denominator because we have a variable denominator. So that means this is not a monomial. Okay? Here we have two parts, 5x plus 7. So two parts are a monomial. No, it's not monomial. Monomial, only one part. Okay? X squared plus 4ab, this is two parts, not only one part. So it's not a monomial. Okay, the last one here, the denominator is 4, and this one can be written as 1 over 4 k squared. Is this a monomial? Yes, it's a monomial because it's just a normal number, which is a fraction, 0.25 times k to the power of 2. Okay, I hope this is clear. Okay, now let's classify type of polynomials. Okay, in the previous we studied only the monomials. Okay, monomials means numbers, variables, or number and variable together. It's just only one part. Okay, we can't add two. This one is wrong. Okay, this is not a polynomial. Okay, now what's the polynomial? Okay, a polynomial can be monomial or the summation of difference of monomial. So now, if we need to call a number, we can call this one as a polynomial, okay? Or if we have a plus, let's say plus something. So this one, we don't call this one monomial, we call this one what? We call this one polynomial, okay? Now, a monomial has one term only. Binomial has two terms because binomial is represent two. Okay, then we have a trinomial. A trinomial, okay, represent the three terms. Okay, like example for binomials, okay, we have 7 minus 2x. So 7 minus 2x, okay, is a binomial. Also 8x y squared plus 5x squared y cubed z. So also this is a polynomial. Okay, sorry, binomial because we have two parts. This is the first part, this is the second part. Okay, example of a trinomial. So as you look to this question here, this one is trinomial. We have this part first, this is the second part, this is the third part. So same thing here. So as you can see, this is a trinomial. One, two, three parts. So as you can see here, we have three parts. Okay, here we have something we call the degree of polynomial. The degree of the polynomial is the greatest value among the summation of exponent on the variable in each term. What do you mean, teacher, about this? Okay, so like this example here. Look to this example. So we have this polynomial. Okay, so this one is a polynomial or binomial. If you said binomial, trinomial, the fourth nomial or whatever, all of them they under the name of polynomial. Okay, so now to find it, we have, I told you, this binomial. So that's mean we have this part and we have this part. So we have two parts. Okay, so we need to find the degree for the part. So as you can see here, x, what's the degree of x2? It's 2. What's the degree of x to the power of 3? It's 3. What's the degree of, let's say, x plus, no, sorry, not plus. So let's say, how about if we have x times x2? What's the degree of this? So we know that this is 1, right? So now this one is x to the power of 3. So let's say x to the power of 4 and x to the power times x to the power of 5. So the degree here, sorry, okay, not x to the power 3. So I mean the degree is 3. Here the degree is what? You just add the power, which is the degree is 9. So now the degree of the of the polynomial is represented by the number. Okay, you add the number with the same variables, same base. Okay, you add the numbers. So now if you look now to this question here, let's take 8xy here first. Okay, so 8x1 and y2 means 1 plus 2 is 3. So the first part of polynomial, okay, is degree 3 degree. Okay, now let's take the second part of the polynomial. Okay, so as you can see here, we have this part here. So this one is, we have x to the power of 3, y to the power of 3, z because no power, so that means it's 1. So now z to the power of 1. So 3 plus 1 is equal 7. So this polynomial is degree of 7. Okay? And to represent the degree of the whole polynomial, okay, to represent the degree of the whole polynomial, we check each part. Okay, the first part is a 3, the second part is 7. So which one is the higher? Is it 7 or 3? 7. So now we can say that the degree of the binomial, okay, the degree of the whole binomial is equal 7. Always we take the bigger, or let's say the greatest degree. Okay, you need to test each monomial alone. Okay, for the degree for each monomial. After you test, you need to state the degree of the polynomial. Okay, let's take examples of this. Okay, classify each polynomial by its degree and numbers of terms. So now here we have this binomial, right? So this one is binomial. Okay, binomial. So binomial, we have this part here. So let's take this part here, 11, x to the power of 2, y to the power of 1, and z to the power of 4. So now just add the powers. 2 plus 1 plus 4 is equal what? 7. Okay, then the second part, 5, x to the power of 3, y to the power of 1, z to the power of 2. Okay, so 3 plus 1 plus 2 is equal 6. So now what is the highest degree? It's 7. So now as you can see here, this polynomial has degree, okay, degree 7. Okay. Same thing. Do the same thing here. This is a trinomial, so you need to test each one. Okay? So test each one, okay, which is 3 to the power of 2. It's 0 because there is no number here. Okay? So as you can see here, there's 3 terms, so it's a trinomial. 3 to the power of 2 has degree of 0 because this one is a number, not a variables. We only counting the variables powers, only variables power, not the numbers power. Okay, so as you can see in the second term here, okay, in the second term, it's n to the power of 3, so degree of 3. Here, this one, it's n to the power of 1 and has its 1. So what is the highest degree? Is it this one or this one or this one? It's this one. So now this one, the degree is equal to 3. How about the last one? Okay, how about the last one? So as you can see, the last one, 5, x to the power of 0, y to the power of 0, plus 5. So x 0, y 0 means 1, right? So this one is equal 1. So this one, 5 plus 5 is equal 10. 10 is a monomial. Since it has no variables, the degree is equal 0. It's same what I told you here. Okay, I hope this one is clear. Okay, you have here some examples, sorry, exercises. Try to solve them and let me know if you don't understand or you have a question. Okay, now the standard form of a polynomial, there's a standard form of polynomial containing only one variable is written with terms in order of decreasing degree. When it is not in standard form, the coefficient of the first term is called a leading coefficient. Okay, what's that mean? Okay, that's mean if we take this example, okay, let me give you this example here. 5x to the power of 4 plus 4x to the power of 2 plus x minus 2. So as you can see here, look to the degree for the variables. So the first degree is 4. The second degree here is 2. The third degree here is 1. Okay, so as you can see here, to write a standard form of a polynomial, you have to start from the highest, okay, from the highest, or let's say the greatest, okay, the highest or the greatest degree, okay, to smallest, okay, smallest, sorry, or lowest degree. Okay, so always when you put it in order, there is an e here, okay, degree. So as you can see, always you just put them in order from the highest to the lowest or the smallest degree. So as you can see here, it's x to the power of 4, x to the power of 2, x to the power of 1. Okay? Then you need to reorder the question, write it in the standard form of polynomial, standard form of polynomial from the highest degree to the lowest degree. And we have the leading coefficient. Leading coefficient. Coefficient means what? Coefficients means number 5, 2, 3, 20, 15, just the numbers. So what is the first number in your polynomial? It's 5. So 5 is your leading coefficient. So now you can say that fourth degree polynomial and the leading coefficient is 5. Let's take these examples here. Okay, now look to this polynomial. So as you can see here, look to each part. This part is x to the power of 1. This part is x to the power of 3. Okay, 1, 3. Here, there is no variable, so this one is 0. Okay, here, 2x to the power of 2. So it's 2. So as you can see here, let's reorder them. Okay, let me erase this because just a number. So let's reorder them. So to reorder them, we start from this part is the first one. So 4x to the power of 3 because this is the highest degree. Then we have this one here. Okay, x, sorry, uh, 2x to the power of 2. Okay, so minus 2x to the power of 2. Then, sorry, then we have the first one plus 20x to the power of 1. You don't have to write 1. Then the last one we write is the plus 1. So plus, so now this is the standard form of a polynomial from the highest degree to the lowest degree. Now, what is the leading coefficient? Okay, so we need to say two things. Leading coefficient, okay. So leading coefficient is the first number in your polynomial. So what's the first number here? It's 4. So the leading coefficient is 4. Okay, what is the degree of your polynomial? Degree of polynomial. The degree of polynomial is the highest degree number. Okay, so what's the highest degree number here? It's a 3. So the degree is 3. Okay, I hope this is clear. Okay, now let's look to this one. So as you can see here, we have z to the power of 6, z to the power of 3, z to the power of 1. Okay, so now to reorder this one, z to the power of 6. Okay, then we have z plus z to the power of 3. Then we have plus 4z. Okay, now let's state the coefficient. So leading, okay, leading coefficient is what? The first number. What's the first number here? If we don't have a number, what we write? We write 0? No. We write what? We write 1, always. Okay, what is now the degree of this polynomial? The degree of this polynomial is the highest degree of polynomial. What's the highest degree here? It's 6. So now the answer is 6. Okay, I hope this one is easy to understand. I told you this lesson is easy. Okay, now let's go to the last part of the lesson, simplifying polynomials. Okay, so as you can see here, when we have variables with the variables, we add them together. Okay, but this variables here, if you look to this variables, okay, x5r to the power of 3. Now, I will tell you something. When we have, let's say, 1r, or let's say 1x, okay, plus 1x, it's equal what? 2x. Okay, so let's say example 2x plus 3x is equal what? 5x. So as you can see, what's the degree of the x here? So the degree of the x here, it's 1. So it's 1. Okay, right. Another example. So let's say we have 1x to the power of 2 plus 1x to the power of 2. So do they have same power? Yes. So the answer is 2x to the power of 2. Another example. So let's say 3x to the power of 2 plus 4x to the power of 2. So do they have same power? Yes. So the answer is 7x to the power of 2. Okay. Why I wrote these two examples? Now, look to this example here. Let's say we have 1x to the power of 2 plus 1x. Now look to the degree here. The degree here is different. We can't x to the power of 2, and here the degree is 1. We can't say 2 x to the power of 3. No, we can't say that because they don't have same degree, okay? Because they don't have, okay, they don't, okay, have same degree, okay? So you can't add them, okay? You can't add them. So what you need to do, teacher? So what you have to do, just keep them like this. This is the final answer. So the final answer is x to the power of 2 plus x to the power of 1. Okay? So you don't have to write this one. Okay? If you write it or if you don't write it, same thing. So you keep the answer same. So now if I ask you this, now 3x plus 4x plus 5x to the power of 2. So what is the answer here? So now this is 3x. It's similar to the degree of 4x. So can we add these two together? Yes, we can add them. So the answer here is 7x plus 5x squared. Can I add 5x squared with plus 7x? No. So this is the final answer. Now I hope you understand. You have if you need to add any polynomial or simplify any polynomial, you need to add only the same power. Okay? Same variables, same power. Okay? If they have different power, you can't add them together. Okay, let's take these examples and finish the lesson. Okay, so polynomials can be simplified by combining like term. Okay, let's combine like term are monomials that have the same variables to the same power. Now, let's simplify the first one. So as you can see here, we have this part. It's similar to the degree of this part. So let's add them together. Okay, before we add them, we have also this part. It's also with this part here. So as you can see here, we have negative 2y3, 2y3. So now negative 2y to the power of a 3 plus 2y to the power of a 3. Okay, then we write this one, negative 8y to the power of 2 plus y to the power of 2. Now let's simplify them together. So now negative 2y3 plus 2y3, okay, it's equal 0. Okay, so because 2 minus 2 is equal 0. Now minus negative 8y2 plus 1, okay, it's negative 7y to the power of 2. So now your final answer 0 minus 7y, which is equal 7y to the power of 2. Okay, good. Now let's simplify the other one here. So we have p to the power of 2, q to the power of 3. Here we have p to the power of 2, q to the power of 3. So we have same powers here. Okay, look to this one here. This one, p to the power of 5, q to the power of 4, p to the power of 5, q to the power of 4. So now let's rewrite them here. Negative 4, p to the power of 5, sorry, p to the power of 5, and q to the power of 4, plus 3p to the power of 5, q to the power of 4. Okay, we finished the first one. Then minus 4p to the power of 2, q to the power of 3, plus p to the power of 2, q to the power of 3. Now let's add the like term together. So as you can see here, the variables, you keep them. You add only or minus only the number. So now minus 4 plus 3 equal minus 1 p to the power of 5 q to the power of 4. Okay, then minus 4 negative 4 and plus this one is equal what 1. So negative 4 plus 1 is equal negative 3p to the power of 2 q to the power of 3. Okay, so now the final answer is this one here. Okay, let's do the last one. Okay, just uh, to finish this question here fast. So as you can see here, we have y to the power of 2, y to the power of 2. Okay, we have y to the power of 3, y to the power of 3. This one here has no friend, so just keep it beside. Okay, now let's start with the green one. So as you can see here, negative y3 x, and here plus y3 x. Okay, then we have plus y2 plus y2. Then the last one negative y 2x. Okay, now let's minus them. So the first one, negative y3 plus y3x. So this one is equal 0 because negative here is 1, here is positive 1. So 1 minus 1 is equal 0. Then plus y2 plus y2 because we know that this is 1, this is 1. So it's equal to y squared. Okay, then negative y squared x, there is no any similar thing, negative 2x. Okay, so now this is the final answer. Okay, so the final answer, let's remove the 0. So we rewrite it 2y to the power of 2 minus y to the power of 2x. Okay, I hope you understand this one. Okay, now you have here this questions, try to solve them and tell me if you don't understand anything. I hope you enjoyed this lesson. It's easy lesson and very fast. Thank you. Have a good day. Bye bye.